Hey Sarah, welcome back. I have a few new ideas, and my first idea was from yesterday evening, before I went to bed. I think it's much better to inverse the characters. So this is already inversed. I do a plus and then the number of elements -1 minus the value of I. So if I inverse this again, then whatever I add to A must be done number of elements -1 minus whatever I have. Hey Naruto, I saw you in a movie. So if I invert this relative to the number of elements -1, I just get I plus get value, of course. But we have to do that everywhere. This is line 344. Yeah, that can stay, and now we are at the top. So here then I need to do the number of elements -1 minus index. And we add that, well, I might as well remove the parentheses. And then we have this one. Name minus A, that gives us the number back. And then we convert that to like that, right? But then now we do need braces because otherwise we get minus minus. I think this should work as in, if now I run it, I should get A, capital A, always in the first group. You see, the way it is now, L is always in the first group. So the first group is just L, and the second group is then K. Unless K and L are in the same group, but they're never in this case. So then the next group should contain the J, unless it contains it here. So this is J, but yeah. Okay, here we have 4 groups. So you see the J becomes before the H. J, H, and so on and so on. But that's not really readable. So I thought I reversed that. Now we have A in the first group. And then B in the second group, unless B is in the first group. But it is still not readable, so now I want to reverse these. This is now, going from Z till A, and I want to print them the other way around. Let's do that first. So that's printing of a group. Maybe what I did was not the best thing, now I think about it. I should invert the sorting rather than this. I mean, this looks super logical if you ask me. We begin at the begin and we end at the end, and that is actually running from 0 till the number of elements. And then I construct an element from the I in a way that capital A, element A corresponds to the least significant bit, and I do not want to change that. That really feels like the only logical thing to do. In other words, value. How does element work? So we make a bit from the index with index to bit. Index to bit just left shifts 1. So if index is 0, which should correspond to an A, I think, then we have just the value 1. And then now I change this function to return A plus number of elements minus 1. Well, in index is 0, I mean. So we get A plus a number of elements minus 1 for an index of 0. That's just silly. Nope, so we have to change this back. I think I changed it all back, right? Should commit more often. I'm not committing at all in this for this project so far. Right, so instead I should change the sorting. Currently calling sort here. Sort is defined as sorting by group. And group has an operator less than. And I want to sort them the other way. So I just can change this. I want to have the A is less. This is the problem. So A is let's say we have a bit mask like this mask, and we have another mask which is like this. In binary, obviously. Then the first one is less than the second one. So we can make them the same length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the reason that this one is less than that one is because of the first bit, obviously. And the bits, the least significant bit is my A. So this is A, C, D, E, G, J. And therefore the therefore it is sorted by the most significant bit, obviously, and hence it is not sorted by A. I want to invert into this bit pattern, and then I can compare them like that. How do you invert a bit pattern? Let's see, M elements is element type, which is a bit set. Don't tell me my bit set does not have a way to invert it. Doesn't look like it. Nope, not finding it. No. Well, let's boomer. Did you say that? Hey, I got 10 for removing trailing comma of a macro expression. Always curious what I typed in. Oh, it's just a question. I have an answer. Yeah, I got an answer for someone else. Right, what do I want to do? Let's go to Google and then ask invert bit mask. Reverse maybe better. Unreadable. This is the dumb way. There must be a fast way. It's unbelievable how long it takes to find something like this. Thought that there should even be an assembly instruction for it. Ah, that's the question. Now give me the answer. Solution is locked. That doesn't help. Oh, lead code. Actually, I have an account here, but not a premium account. Is that going to make a difference? I'm yeah, must be premium. Okay then, fuck off. Finally we are there. This is for 64-bit. Reverse the bits in a byte with 4 operations. Why not turn this into a utility? We have a byte. Probably should go to the top. Find the reversing bit sequences. The obvious way, you mean the stupid way. Reverse bits in word by lookup table. Reverse the bits in a byte, 3 operations, byte, byte, byte. Reverse an n-bit quantity in parallel. It's 5 times the log of n operation. I think with parallel I mean that I do it the smart way, not using multiple cores. Yep, this is the one that I was looking for. I cannot believe I do not already have this. It should be something with, say, a lot of 3s in it. Damn it. stb image.h is using it. This is bit count. Well, that's almost the same thing. I was looking for that time maybe. I would definitely put that in here. Well, I guess I did not. I think I'm using assembly instruction. It's pop count, right? The number of bits. Yeah, it's using built-in pop count, which might or might not do the same thing as we just saw. So maybe there's a built-in version to reverse bits. What do you think? Well, then we would have run into it. Okay, I'm going to make a new utility. Let's do that in this util here. Let's make a new utility that inverses the bits, and it's going to look a lot like one of the other bit manipulation stuff, in the sense that I need it to be dependent on the type, I think. So something like this would work. Let's see if I have another one that comes close. And that, of course, is exactly the same thing. Yeah, this one comes pretty damn close. Also with an some kind of algorithm. Reversed.h, yeah, I think that's something totally different. It's an iterator. Okay, let's use this one. And now you need a good name for it. What is a typical name that people use for reversing? Okay, so holy slow. I clicked on it, really, I did. Clicked on it again. Why is nothing happening? Various processors have an instruction to reverse the bit order in a word. I think my mouse died. Oh, there it is. R-bit, that's what they are using here. These guys are professionals, obviously. ARM is just probably the processor. The built-ins already produce better code than the generate bit reverse implementation. I guess the built-in still does not exist because they stopped at 2021. Shall I add a comment? This is yeah, see, I even have a domain name, gcc.knu.org. Hopefully that means that will take me seriously. What the? Gotta be kidding me. This is well, it's literally in my database. So I guess they threw me out or something like this. Didn't log in for long enough. I'm gonna paste my password in here. It's much shorter. Update my password. I don't know. Apparently it still worked. Yeah, okay. So we do not have a built-in. If we don't have a built-in, then I'm afraid that we probably cannot get any faster than what I found on this BitHack site, which I didn't lose. It's here, so we'll have to do it like this. Then I'm going to copy it to rbit.h because that's what the other people used, but I don't like abbreviations, so maybe I should use it. Should call it this time some a little bit different than rbit. I mean, I'm also using MSSB for those reasons. That is just the way that people talk about this. CTZ and CLZ and stuff like that. But okay, this is the counter left 0, so the number of zeros on the left. But what is CTZ? In the end, it's not helping, right? This is the most significant set bit, I think. Yeah. Yeah, let's use a, I don't know, rbit. I mean, it's not even a built-in yet. Let's call it let's call that reverse bits. Okay, I'll just do it in the whole file. MSSB becomes reverse bits. Now this is the actual entry function. Utils reverse bit end returns value where well, I don't think this is the best description. What would be a good description? that a good description? So let's say n is 8. We're going to swap all the bits of a byte. And then n runs from 0 till 8 divided by 2, aka 4. Less than 4 means 0, 1, 2, and 3. And we swap that with, well, the 0 is then swapped with 8 minus 1 minus 0 is 7. And so on. So I think the description is correct, although it's not maybe not really totally 100% the best description. Can add an example. I think these days we have a way to make a binary number finally, but I forgot how. Seriously. Isn't that like 0b? Is that a binary number? Uh-oh, I don't know anymore. Let's see if we C++ enter binary number. Yeah, 0b and then a binary number from C++ 14. So it exists already a while. So let's say we begin with 1, 1, 0, 1, and then 0, 0, 0, 1 becomes 1, 1, 2, 3, 1, 0, 1, 1. Also binary. It is my job in the sense that I do nothing else and have not been doing anything else for the past 25 years or so. I've been coding C++ for 28 years. But if you want to know if we get paid for it, nope, I get not paid for it. Static assert standard is unsigned value and size of t. I think that still holds, right? Isn't there an is unsigned v? Yeah. Not that it matters, but is unsigned a value of t, what is a boolean? And well, I don't not really see any reason why I would limit this to int64 type, but on the other hand, for now I'm not going to implement uint 120 type. I should. I'm not even sure if it exists, I have to admit. I literally have no idea that it exists, you know that. Let's try that out as well. I guess that if it exists, it should be defined in C standard int. Uint 120 type x is 42, of course. No. Well, at least this compiler Clang doesn't know about it. Well, that's good enough for me. I'm not going to support that then. Now, the extended probably means something else, but well, I only know really Dutch and English. I can understand German, but not speak it. And I'm using Arch as operating system. Extend reverse bits. Right, and then I have to implement it for each size. So inverting the bits of a byte is probably the fastest way. Is probably the table lookup, right? Let's reverse the bits of a byte with 3 operations, 64-bit multiply and a modulus division. Well, I'm not convinced that is faster than 4 operations with a 64-bit multiply and no division. How fast is a multiply these days? Yeah, I'm not sure about this. It all looks slow. When I write a utility, I want, of course, the fastest way possible. I think, how large is a cache? Isn't it like 64 bytes or 32 bytes? So a cache line, I think 64. So what table this? You need 265 bytes. That's 8 cache lines. It's too bad I don't have a benchmark for this added to it. I'm just going to Google it, I think. 64-bit integer multiply clock cycles. This floating point. I don't want floating point, I want integer. Did I say one clock here? Enter. Well, I did quite a lot of languages in the past, but it's safe to say I've got all of them. I mean, I'm not doing it anymore. I'm only doing C++. And experience is also important. You have to keep training, as it were. So I don't think I really know any other language than C++. I don't know anymore what they're talking about. I saw and multiplication takes 13 clock cycles. And here I see if you have large arrays of 64 int to multiply, both have a throughput of 1 cycle. But. Is integer multiplication really done at the same speed as addition 8 years ago? Integer multiplication will be slower. They will show that 32-bit integer register add sub take a quarter to 1 cycles, depending on how well pipelined your instructions are, while multiplication takes 2 to 4 cycles. Still pretty fast. But okay, integer multiplication take 3 to 7 cycles. Let's go with multiplication is at least 4 times slower, and maybe more. So this does 2 multiplications. That's already then, let's say, 8 additions or 8 other operations. And then 2 more, that's 10 in total. And this is 7, so this one is faster. I'll just go with this one. Oh, wait. Multiplication. No. The difference is, yeah, this one has to be faster. This one uses 64-bit multiply, and this one uses 32-bit multiply. Okay, so we got till, what was it? Something like 10 or so, or maybe a little bit more, but this is even larger. Well, the log of n in this case would be 3 times 15, so it's questionable. But the fact that it is being mentioned, okay, we're going to do this one. Reverse the bits by the 4 operations, no division. And then for the rest, I'm afraid we'll just have to use the same algorithm. This one. This one is written for 16 bits. Was that 16 bits? 32 bits. Unsigned int, well, that's my n, I guess. Reverse in bit. Nope. Okay, and then we have to do this for 16 bits. Well, that's hardly faster, unfortunately. If you ask me, it's just going to convert everything to an right or not right. Somehow this one doesn't collapse into that. Yeah, if you do this shift, might as well not do the end, I guess. Do an end with it and then we shift it away. And here we do same thing, right? Oops. Something like that. I don't know if it makes a difference to make these ints or unsigned ints. Sorry, unsigned. I mean, change a little. You can tell the compiler that the literal is also 16 bits. But that should not make a difference, right? The compiler cannot figure out that it is smarter to use the certain size. When you give a little, then I give up on my compiler. And then here we get, yeah, well, in this case it must be an unsigned long, because it cannot be an integer. But if I actually if I type it like this and it doesn't fit in an integer, I think it's going to convert it automatically to a longer thing then, or not. Not even sure about that. $16, and then this becomes that, right? I'm Sibu asked, how do you understand all of that? Well, experience. So we go to my homepage. I worked on M4RI. Yeah, employs a library of fast arithmetic with dense matrices over F2. So that is an F2 means just Z2, so 0 and 1s. So you have a matrix with just zeros and ones in it. And I worked on the transpose of this. Actually, I just inverted all the bits in the whole it says here, bit level optimization, transpose, column swaps, refactoring, benchmarking. So that's the kind of experience that I have here, 4 bits. And then if I see this, it's just, yeah, I recognize it as it were. It's easy. If you just draw it out, you follow exactly what happens, then you'll eventually have to admit that it is easy. Of course, if you see this for the first time, then you think, what the hell is going on? Which does not mean that I cannot make a mistake. So theoretically, I should test this, and maybe I will. It's boring, but probably a little bit premature to just assume that it is now bug-free, right? So let's write a really small test program quickly. Reverse test. Not even sure if I have CWD. I don't think you can print binary. So normally just cast it to a bit set or something like that. A standard bit set with the size of 8 from n. Is that going to work? Error in partitions. fail. How can it fail that hard? How did I do something wrong here? What? That is the input. It's not reversed at all. Ah, indeed, it's not reversed at all. I'm just printing in. Okay, well, let's print it twice then. So this is the original, and now we're going to print utils reverse bits of n. Yeah, that worked. And now you do the same thing for 16. And then you have to come up with some pattern. Yep, that's correct, right? And now you have to go to 32. Now I'm getting lazy. Just did something random here. And then hope that it is 32. Apparently I typed too much. Is this 32? Yeah, what? I want to. Okay, 110130 is 1110 ones. Now we are halfway. This shows 0, 1, 3. Yep, okay. And then the worst one, 64. How much more do we need? 8 bits. I think this is 64. It's not. And that fails. That does look like 32 bits. Yeah, that's better. Oh, I'm just going to highlight this. It's way easier. Okay, and then we can go from here. 8, 8, on a 1, 0, 0, 1, 0, something. Okay, so that works. Well, great. All the time, test something that we knew was working anyway already. Really, sort of. Don't need this anymore. I'm going to remove it. Now, what did I need it for? MRXSTG. It's suppose you're working on something, and then in order to make progress, you need to solve a certain problem. problem A, and then you work on problem A, and you need problem to solve a subproblem, which is subproblem B, and then while you work on B, you run into something and you start to work on that because B needs C. And now while working on C, and that goes on a while, and that's where I am now. And A is then the game engine, yes. You won't recognize it. But unless you stick around for a few months, then I'll definitely get back to A. No, seriously. Why did I need a bit reverse? Oh, I remember. For my sort. So, okay, yeah, this compares group. So instead of comparing group the way I'm doing now, elements, element is a bit set. Which apparently automatically converts to a mask type. What if I do utils reverse bits on elements? Will that compile? While I think about it, I'll compile it. And the answer is no. Static assertion failed. Type of the argument to reverse bits can only be. And what is it? With T is bit set unsigned int. Okay, it's not automatically converting when you pass it to a template that takes anything. So we have to explicitly convert my bit set to a value. I think that I already remember how to do that. I thought there's just two parentheses after it, but let's look it up anyway. So I want to convert this to the mask type. Here it is. Mask type you get with indeed two parentheses. So we have a bit set, and now we have a mask type. That worked. So now we run partitions. I think it should print everything alphabetical order now, which I think is much easier to read. No, I do not use row blocks. Okay, this takes a long time. Maybe should reduce the number of bits. But I'll wait for once. In the meantime, I guess I can talk about what my next step is. Oh, there it is. So now I think it's much better readable. We have A always in the first column, and then either B, C, D, E, F, etc. if it is in the same group, unless it is not in the same group. For example, if B is not in the same group, it's in the next group. And the same thing, then C follows the B, unless C is in the first group, like here, or in the next group. But you would never see the C, let's say, in the next group after that. And then, yeah, it's just ordered alphabetically now. So this word, if you look at this as a word, these elements are ordered alphabetically, and then the words are ordered alphabetically. So the A comes before the B comes before the G. I use Malakar. You want to know what the subproblem above this is? Above this one? In the end, I'll go to problem A or B or something like that. In the end, I want to use this to find an optimal way to divide shader resources over descriptor sets in Vulkan. But it's all so far-fetched that I wouldn't worry about it. Just look at it as an interesting problem, all by itself. Which I think it definitely is. Because my next step is, I want to find an optimal, the next step, closer to the current problem is that I want to find optimal partitioning where each pair gets a penalty or a weight. So these are the elements that I have, and then each pair, for example, df has a weight of -1, while AK has a weight of 100. If you put two elements in the same group, you have to add this score here. If they are not in the same group, you do not have to add it. So what you want to do is put everything that has a positive score in one group, and then everything that has a negative score, but with relative to these, but a positive score relative to each other in another group. But that's of course not possible. You will always be forced to put certain elements that have a negative score as a pair in the same group, because in the end you are better off. I now made an algorithm, or rather it's using two algorithms. It's running one algorithm until there is no improvement anymore, and then it runs a second algorithm until there is no improvement anymore, and then it stops. If there is an improvement, it goes back to the first algorithm. So it stops after both algorithms cannot improve it anymore. And then the result is this. And the maximum score is this one. So this is the solution. This is what it should have found. But sometimes it gets stuck on this and this. You see, since the evaluation is lower for all of these, you can call those local maxima. And so it's like you are walking somewhere and you want to go to the highest mountain top. And the way to go there, you walk always uphill. Well, the result is you will walk uphill until you reach a top, but it might not be the highest top. It might be a local top that is lower than the highest top. So that's what is being doing here, and you see that from the millions of possible partitions, because we have now 12 12 Why do I keep closing that thing? Because I keep needing it. And I keep forgetting the... Is it I-O? It's something with I-O? Nope. E-I-O? I'll have to use the same trick again. U is. What does it stand for? Oh, online encyclopedia of integer sequences. So the O of online, and then the E is in encyclopedia. O-E-I-S. I hate abbreviations. Oh, oops. Online encyclopedia of integer sequences. Okay. And now we type that here. What is this? Now we can click on my history link. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's only 4 million. So this many partitions exist, which means that if we add all these numbers, I should get that number back. Now, of course, I'm curious. You know me. 39009 plus. Where's my plus? Yeah. 508285 plus 130801 plus 275769 plus 2 4 5 5 4 5 8 plus 804275 equals, yay, no, that's exactly the same number. So this is the total number of partitions, and then for any partition we end up either in the solution or in one of 5 local maxima. Now what I want to do is that every time I get into a maxima like this, wait a minute. See, this is way smaller than this one. Really, so it's 5 times smaller. Well, actually, compared to it's 1/8. The number of partitions that end up in the solution is only 1/8 of the total number of partitions. So if you start in a random position, you have a chance of 1/8 to find the solution. So what I want to do is I start at random partitions and I run my algorithm. And then the question is, how often do I have to do that? So I can be almost certain that I did found this one. So that would be 7/8 to the power something such that that is extremely small. Extremely small would be, well, I don't care that much. So 99% sure would be enough. But let's go all the way while we're busy anyway. 99.9%. So very small, 0.001, and then I need the the 7/8 log of that, right? So probably I need to take the log of that using a real calculator right now. Let me do. I think I need just the log of 0.001 divided by the log of 7 divided by 8. That's 51.7. So let's say 52. So if I generate 52 partitions, then the chance is only 0.1% that all 52 missed any of these. And if even one of them is in this group of 500,000, then I will find the maximum. Right, but that means that I must generate random partitions. And I want those random partitions to be well, uniformly distributed over all the partitions. So I'll have to generate a uniformly distributed integer in the range of 0 to that 4,230,597. And then I have to convert that integer directly into a partition. So that's our new subproblem. How can we do that? I think that's a very interesting problem. And I have no idea how to do it. However, suppose we knew in advance that we had 3 groups. If you know the number of groups, it becomes a lot easier to, I think, do this trick. I mean, A goes in the first group, and then B goes into the first group or the second group, but never the third group. Although you still don't know how often it goes in this one or this one. It's probably not 50-50%, right? Okay, let's go to less bits. Let's use 5. 16 bits is enough, even though it doesn't matter at all, of course. I think this should still work. Yeah, now we don't have any local maxima, but I don't care about that. What I wanted to do is print all the partitions. So I have to change the whole program to not do what it currently is doing, but to just print all the partitions. I don't know what's happening. I think my keyboard is broke or something. I type Shift V and then J, and now it works. Oh, and I did that before. Oh, I think that's the reason. Yeah, my keyboard is slower than I type. If I press the Shift key and I let the Shift key go, then often the keyboard still thinks that the Shift key is pressed when I press the next key. So I pressed accidentally a Shift J, which concatenates the two lines. Blub. 3 lines have been copied. We go to the top, just abuse this file because it has so many other good things. We're going to run over all the partitions, so this way I can just print it out. Let's call this thing P. Thank you, Roman. So this is these are all the partitions with 5 elements. And now, so how many is that? 5, 1, 2, 3, 4, 5 is 52. Yeah. Ooh, this is also 52. Coincidence, I guess. Absolutely 100% coincidence. Yeah. So now I would have to generate a number between 0 and 52, and then each number must be mapped directly onto one of these partitions. And we can test that by just doing that a lot, and then see that we get the same amount of each of them. But before I can test that, first I have to write it, of course. Okay, well, we can begin with printing the number. So the actual number is some integer, let's call it n. And I want to print n then. Let's give it a certain width. Standard set width. Well, 4 is enough. And then separate it from the partition itself with, say, colon. And then of course you have to increment n afterwards. So this number must be converted to that partition, and so on. But nobody knows what this is. It's not a really ideal way to work with, I think. I think that a better way is probably to just print the group that each element is in. aka A equals 0, B is 1, C is 2, and D and E are 0. So instead of printing P, I want to call a member function on P that prints, let's say, print groups, the groups that the thing is in. 1, 2, whatever. I'm always printing to standard out in this case, so I might as well just print groups and then print to standard cout, I guess. Hello, postcard. If you're talking to me anyway. Print groups. must be added to partition. I have a print on, let's put it in front of this. And then we want to run over all the elements and then print the group number, right? It's way easier to, let me think. Funny thing, the fastest way would be a matrix transpose. If you look at this, a group here is a bit set. So if I see a bit set as a row of bits, then you can see this is a matrix. If I would transpose the matrix, we would swap the group with the elements. And then I can run over the elements and get the group. Haha. And there are super fast algorithms to do that. But let's not go that way. Because this is probably not needed, because I'm printing it anyway. Printing is super slow. So instead we're going to do something super boring, and that is simply run over all elements. I guess that would be an element index, right? And then do it order n squared. So running over all the groups. Do it like that. Right, and then we print, well, until we find that the group contains that element. Laser blowfish, I have not used ranges yet. I think I tried to use ranges once and that didn't even work. So I don't know. Might be cleaner, but then I have to learn something new, which is not going very well. So the benefit of learning something new is at some point disappears. Not even sure. I mean, how would ranges help me exactly? Or do you mean the colon thing? Like this. I mean, that doesn't work because this literally calls begin. And my thing is called I begin. So that won't work. Oh yeah, well that's what I just said then. I needed to call I begin and I end, not begin and end. Yeah, I know. I use that whenever possible. But it's not possible in this case because that's literally translated to calling begin and end. So you don't gain anything. It's just a little bit more lazy to write. But I use that too. I'm sure I can find it. Well, not like that. Yeah, here's an example. I used it. So not too many. Oh, here's another example where I used it. But like I said, it's not possible here. So if I is in, I'm going to call it E because it's an element. And the other one is called G. If we find the group that this element is part of, we want to print the element to see standard out, apparently. So I want to print the element, I want to print the element as the element, I think I want to, so let's try this as element E. And then an equal sign, and then the index itself. No, this is not what I want. The group that I found it in. And I use a prefix or a separator. Probably separator is a better word, but prefix shorter. Okay, I'll type how do you type that? Separator, like this? Guess so. And then the separator between those things is just a comma within space. Looks good. Character const pointer separator must always begin empty. Don't think about it. Empty. So the first time we get here, the separator is empty, and then afterwards you put a comma. How long we've been coding? 46 years and 28 years in C++. So is this going wrong somewhere, or did we already do it? Doesn't feel right. If it compiles, it works, right? Let's try that. Well, it compiles. No, for some reason I'm not seeing any commas. Oh, God. Sorry. I confused the... No, I didn't. Well, I confused something. I think it has to go there. Okay, that's better. My indexes are printed with a hashtag, which is might not be very readable in this case. Often in debug output, it's nice to know that it is one of my indexes. But in this case, I just want to see the integer value of it. So instead of printing G, which is a group index, I want to print the value of it. And I can do that by just getting get the value of it. Okay, the challenge is now convert this number directly into these numbers. And then for every number. Well, I would say machine learning is exactly what we need here, but maybe we can do it ourselves. There is one thing I see. A is always 0. Well, I already knew that, but that was an easy one. And indeed, B is always 0 or 1, but it's not 50-50. You see, it is not as often 0 as that it is 1. And now we get for C, C is indeed only 0 or 1 or 2. And also not really, maybe, yeah, I don't know. We have to print the number of times it gets each value. Well, that's quite a challenge, I think. How can you do this? If I knew the frequency that, say, let's say I know how often it is a 0 and how often it is a 1, then it could also generate a random number. That is just distributed according to the same ratio. And then I would have my A and my B. And then the ratio that C is 0, 1 or 2 might also have a formula, but that formula is then probably depending on what I generated before that. For example, if B is 1, then C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 10, 10, 17. And if B is 0, it is 1, 2, 3, 4, 5 against 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5, 10. If you can find that sequence, looks like a triangle of numbers, which we might be able to figure out. That would not be converting from here directly to that though, but it would give the same distribution. We'll probably need the triangle anyway, right? It's the point where we switch. So let's say if I had this triangle of numbers, meaning I have the number 5 for the C, so I just know that C goes through 5 zeros followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. Then I also know 15, which means that if I generate, say, 17, and I see that 17 lies between 15 and whatever number this is, I can, that's literally this number here, 17 lies between 14 and 25, therefore C is a 0. Okay, so I think we would get some insight there. How can I turn this table into a triangle of numbers? Let's think. Well, yeah, okay. Someone asked when you start learning C++. Let me calculate this. So what is that was hard. 2022 minus 28. Well, I guess you just joined, right? Triangle, triangle, triangle. Let me think. It's 1, 2, 3. Yeah. I think my triangle needs to look like A is 0. %100% correct. B is either 0 or 1. So it is 0 or 1, but really I want to know how often that is the case. So in this case we have a total, we have a total of 52. So really it is 0 because this diagonal here is 0. Sorry. You cannot, there are no ASCII things that are, what is this, like 45 degrees? Ridiculous. Could not find it. I mean, not ASCII, but UTF-8. Nah, there must be a 45 degree, come on. Could you? UTF-8, 45 degree arrow. That's what I really want. Arrow symbols. Diagonal arrows. Yeah, this one. No, it's just 0. That's so small. Ridiculous. But okay, the 0 is this, and then we have 52 of them. So A is 52 times 0. And B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 0. And then C is 1, 2, 3, 4, 5 times 0. Well, I already recognize these numbers, or am I crazy? 52, 15, 5. 52, 15, 5. So the next we get 2 and 1. And yes, we do. D is 2 times 0 and E is 1 times 0. Ah, ha, ha. The pattern has been discovered. Well, not really, but maybe sort of, you know, like 1, 2, 1, 2, okay, so 1, 2, that would be E. Okay, now A is never 1, but B is 1. And well, the remaining part, so the number of times that B is 1 is 52 minus 15 is 52 minus 15, 37. Am I correct or am I correct? Of course I'm correct. So these are 37. 37 up on the 0. No, what if I do a Y here? I didn't select anyone. Control V, Y maybe? I don't know. P, that's better. So how often is it 1? It is 37 times 1. Now the big question. What comes here? Well, that's how often C is 1, of course. But is it? Because C is getting here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 1. But only when B is 0. And then here it starts again. More ones. We have to separate those, I'm afraid. Yeah, we have to separate those. We have to be specific that this is about the B that is being 0. So it's not a triangle, unfortunately. It's a tree. Nevertheless, I just happily continue with the tree. So if B is 0, then C is 1 5 times. Yeah, I already said that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times it is 1 when B is 0. And when B is 1, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 0. Which happens to be this 10. Could it be true? For now, we're just going to assume that this is a pure coincidence. Let's shift this up a bit. Yeah, I'm not seeing a structure yet at all. Have to fill in more things. We're at 10 times 1, right? And then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 0. I already have that one as well. And then we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times I already counted those. Okay, 10 times a 1, and then we get even more of those things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, I counted those already. So it's more like 10, 17. I think I'm better off by doing it like this. This is 0. And this is 1, and this is 2. That's how often they appear. In the case that B is 1. Sorry, diagonal arrow. We didn't need you. There's a lot of work, so I'm starting to think that I should maybe write a program that just prints this. But printing ASCII values like this, it's never easy. But it's a tree, so you could make a tree that stores... well, this is a vector, and then we get inside the vector we have vectors. No, it's a tree. Every time you go one branch deeper, we go to the next element. And then the branches are numbered. Hi, Fatman is back. Welcome back. You could use. I could make a vector of a vector of vectors of vectors and so on. Five deep. Or I could make an object that represents one tree. And then a tree exists of a vector of those objects. Quite obviously, this 17 is 37 minus 10 minus 10. And this 10 is 15 minus 5. And this 37 is 52 minus 15. And this 52, 15, 5 to 1 is the sequence that you already know. So the only unknown here is this one, maybe this one too. How do we get this 10 here? Well, this 10 could be equal to that 10. There's a lot of 10s here, so you can hardly draw any conclusions yet. I have to fill this in. I want to see more numbers. Okay, shall we write a program? That's gonna take time as well. So, yeah, I do want to see this, I think. So I'm going to make a class that represents a tree. The tree is, for example, at the top it's 137, and then we have branches. The number of branches is not even known yet by looking at this. I can just make it a vector. I don't know how many, so. Okay, so our tree has a certain information at the top, which is 2 integers, and then we have a vector, and the elements of the vector is another tree, just like this one. It shouldn't be too hard to code. I think this file is running full. I should split it up. So let's split it up. Right. So we'd have to edit this header then to set the number of elements. Oh, I guess. Yeah, there's lots of classes, right? We're not done yet. Element pair dot h. Let's keep putting this in all the prints on and CXX files. We need an access cert apparently. Mm-hmm. Strange. How did I get away with not including that header? Partition is the next one, I guess. Might as well copy it immediately, I have the feeling. No. Let's clean it up first. So H. Okay, what shall we all put in the .cxx? Why not this one? As well do the is sort inline. Just a call. Wait. Yeah. Light like that. Maybe I should try to compile it first now. Made a lot of changes. No. This one. Still have to do the partition iterators. That's a lot of stuff. And these can be moved to they cannot be moved yet. Let's not move them yet. Yeah, good. Why do I get so many pages of errors? Oh, I think I know. Yeah, where is that defined? In partitions, we hope. Nope. Well, it should be then. So we're going to copy it from invalid source. I guess it's in AICXXN. Also not. Gotta be kidding me. Yeah, slightly better. Okay, this here needs utils bit set.h. Oop. Can I just remove this old thing? It's getting in the way now. Defined in elements.h, obviously. Does that include xassert? It does. Let's just not do that here then. Hell, it even includes iOS forward, I bet. Yep. That should be enough then. And then we get strong ordering is not a member of STE. Okay. What should I include then to get that? Include compare. That's telling me how nice. We need that here. Okay, standard strong ordering. Hmm. Assuming that the group already includes element.h, it does. So everything includes everything. I don't know, let's try to compile stuff. Element pair. What is this doing here? Why is it not part of element pair? Maybe I should put that in score. I'm gonna need score now anyway. Oops. Oh. My mouse is broken. Okay. We are back. That is... no, I stopped paying. It's a boring club. So I'm not an official member anymore. Okay, let's see. There was one more thing. I wanted to make the... think I became a member when I was 26 or so, ish. And then stayed 2 years a member. But the people that you meet there, they are really strange. To summarize it is that they have failed in life, mostly. And then they did an IQ test, and that they scored high, and then suddenly they used that as the excuse of why their life failed, why they cannot deal with other people and stuff like that. So when they have get a fight with the boss, say, and the boss fires them, right? So now suddenly it's not their fault, it's the fault of the boss. They are just smart. And then you have to, the things they talk about is like, you drop your mouth open. Like, there were people there that were completely convinced that things like, I mean, all kinds of nonsense, like, say, astrology. They believed in that. Most people were alpha guys. I was going there for have a good chat about quantum mechanics or something like that, but I could not find anyone. Only touchy-feely people that lost reality, lost touch with reality in my eyes. And bathing in self-pity and stuff like this. I don't know. Well, that was back then in that one group, of course. Later, I was much later. I was already in my 50s. I was in Amsterdam, moved to Amsterdam, and there I had a girlfriend who desperately, she kind of collected intelligent men. So just as if some guy is intelligent, and she was like, so that's why we became friends as well. And she thought that she was very intelligent. Yeah, kind of, I guess. So she desperately wanted to become a member of Mensa. So he was making one IQ test after another. Every time she failed, and then next year she tried again, until finally she succeeded, and she she was become a member. And then she wanted me to become a member again. So all I still had my card. I just had to start paying. And then I went a few times with her to meetings in Amsterdam. So completely different time and a different group. It wasn't as bad as my previous experience, but it was still boring. And I couldn't really find people that you could really have an interesting conversation with. Even though I have had interesting conversations in my life with, just students from the university, people online. There's just not that many people that you can have a really, really interesting conversation with. No. I don't think introvert or extrovert has a relationship with it. Let's say the boss of ASML here, now I gave away that I live close to ASML, but that's an intelligent guy, right? He's running a company that's, look it up, you probably know already. A guy like that is not a member of Mensa, if you get what I mean. He's running a business. He doesn't have time for stupid clubs like that. So you won't find that kind of people there. Yeah, my code has nice colors, I know. I forgot what I was doing now. It just worked. And then I wanted to move the partitions, I guess. Yeah, when I worked, I have worked for a short time. I had conversations with the boss of my boss. My boss could not deal with me apparently, and then at some point the top manager of the whole building was going to take care of me. So he became my direct contact for my job. That was a smart guy. I mean, I could have really interesting conversations with him. I guess you have to be smart to run a whole company, right? I want to move partition iterator to its own file. Do I want to put all the iterators in their own headers, or shall I put them all in one header? Not anymore, I think. No. Well, I don't know. Maybe. The thing that really got worse for me is my memory. And I think that is important. I think that, well, typically for me is that I think I have a quite dense packed neurons, if you get what I mean. And they were firing pretty quickly. So I had a kind of unstable mind. But I could also feel it in this thought processes. So kind of thoughts. You think about something that you are kind of experiencing of explosion of thoughts, basically. So, billions of neurons firing all at once and doing stuff. And now I feel stumped off, dead, you know. My brain has gone silent. Ish. It's not like it was, but it's I'm more stable now, so that's better, right? I copied this, and I have to copy this to that, and let's call the header again. This is really boring work. I should not even be streaming this, I think. But everyone is free to stop watching. So why not? Let's copy it to that base, that header file, and then remove it. Let's begin with removing it, or begin with adding it. Let's begin with editing it. And this is a header file, so it begins with pragma once. And then, of course, I have to delete everything that is unrelated to it. And then we have the whole class, so it stops here. Or, I can at least start with putting single element and the whole group one in it. The brute force maybe not. Let's do that in its own header, because it's not even derived from this one. And then I need to see which headers I need. So group index, that would be this group. Another group. Group. And group includes everything else, so why am I even still looking? It looks like we just need group. And partition here. The partition might yeah, okay, we need partition. Which includes group. So I can just include partition.h. And now we have everything. To have partition.h. And then see which one we want to keep in line. Well, most are very short, so we can just keep everything in line. This class also. Oh, this is something bigger. Okay, I could theoretically move the increment here to the .cxx file. There's another increment here. So maybe let's make an CXX file out of that. So that means that start with this one again. Hey, what? I didn't copy it, I moved it. Scary shit. Well, these are virtual functions anyway, so they're not going to be in line. Extremely unlikely. Okay, I think we have that covered as it were. It's kind of silly to put this in a CXX file that is named partition iterator base, but whatever, right? That compiled immediately. Then there's one more thing left, and that is the brute force iterator. Oh, ooh, I have to delete itself. which includes partition, so I only have to do it like that. And it probably also includes element pair. We'll never know, but maybe we will, because I tried to comment it out. By now it looks kind of silly to just include an iterator and then expect everything to exist. Maybe you shouldn't not do that. But then again, that iterator really uses everything. So it might as well. Okay, so the last one was iterator brute force. There is a partition iterator here. What the I think that should go in its own header. Also in its own header. And these are templates that depend on, they're actually part of partition, so it should go into partition header. I'm using NeoVim. I type VI, but it's really NeoVim. Okay, I'm getting confused now. Element pair is not declared here. The reverse, I'm going to clean this up a bit as well. Reverse bits. It's no longer needed. Multi-loop is also not used here. It is used, but that's the brute force one. Okay, let's first move everything, I guess. Yeah, sprint on should be included in element, however. Element dot h. It's already there. Array was also already included everywhere. So still using it here, but. I don't think I'm using index. I'm using a lot of indexes, but not that index. And bit set, yes, yeah, elsewhere, right? These two, elsewhere. Debug, I'm not even using debug actually. Yo, stream, IO, manip, C standard, int, yeah, well, C assert is already, array of course also. Compare is no longer used here. Random is. Algorithm also no longer. Memory, I don't know. Chrono is set. Let's keep it at this for the moment. Oops, does this still compile? And then I want to copy, let's say, the brute force thing. Well, I already have debug output that prints this now. Let's delete it. So, I mean, nobody understands this code anyway. It's using multi-loop. Nobody will understand it. Maybe I should add a comment to make it a little bit, increase the chance that someone understands this. Yeah, and these should go to partition. Let me see. Wait, oh, no. What am I doing? This is... Okay, I'm confused. No, it was correct. By the way, I have to mention that it's actually not correct to use double quotes here. I have the habit of using double quotes when there are my header files. But correct would be to use this, because double quotes only means that you want it to search in the directory of the current file. Now this utils is in the root and this is in source. So utils is not in source, so there is no reason to search in source for it. But well, I cannot shake that habit. But if you're beginning C++ coder, then you should only use double quotes when you want to type a path that is relative to the path that the current file is in. Methinks. Yeah, number of elements is defined in element.h, right? So I need that as well. It's also good to always include from the most dependent to the least dependent. So first the local header files that belong to your project. Then I include any header files from independent projects of myself. Then I include header files from third-party and then lastly I include header files from the standard library. And the reason is, of course, that if I would do it like this, I would never catch the error that in element.h needs to include array, because it is already included. If you go in this order, then you force yourself to have the top header include everything that it depends on, and not accidentally think that it doesn't need something because it was already included in the file that includes it. And see, you have everything right here. Yep. And I don't know. Let's try to compile it. Partition does not name a type. So we did not have everything. Now partition also includes element.h. So just delete it here, otherwise it feels a bit stupid. A linker error. Oh, multiple definitions. Yeah, I didn't move that one yet. So I wanted to move it to... actually I did move it, but I did not delete it, or what? I did move them, but I did not delete them. And the brute force was already moved as well, right? So you have to delete that here. They should also go to partition. Let's move this one to partition. Let's move them both. Yeah, okay, so now I need the partition iterator to be in its own header, otherwise we don't know what it is. I'm just going to compile, see where it goes wrong. Partition iterator is incomplete. This is a header file. Partition iterator. Returns partition. So we need to define partition before partition iterator. Therefore, we can only include it here. And then we have a possible problem anyway. Yeah, see, bad memory. I cannot remember anymore how to fix this, because it's something I invented the last year. The only thing I know is I wrote the Stack Overflow answer for it, so I can look it up in Stack Overflow for my own answer. Yeah, it's simple, but it doesn't stick. It doesn't stick in my memory. It's really annoying. Can also try to look at the Linux Viewer project, which is using this a lot as well. Yeah, for example, this one might be using it. Nope. Yeah. Yeah, this is the simplest way to do it. I think that might suffice. So I have we need gods, include gods, and then right before the end I include what I need below that, and then we end it, and then start another include god. I would rather use the more general case. See if I can find that. Yeah, like this. So in that case we just end the guard. So this guard is a logical vulkan device, and then as soon as the guard ends, we do the includes that we need below that. and each include has its own if not def around it, and then here we have again the guards with an underscore definitions after it. Right. And then these guards use Vulkan timeline, same for .h, which I guess is just a guard around this, which is defined inside this header. Yes. Which does the same thing with for that header that we were using. Okay, do I now have it? Guards underscore definitions, and then in between here, yeah, I think I have it. If not def partition.h, define partition.h, and if partition.h, and then we need here if not def partition.h definitions, define partition.h definitions, and if, and then also this one is if not def, and then the guard of that one, partition iterator.h, and then partition iterator needs to use that as a guard. This is CXX file. Whoops. Oh, I didn't move it yet. Well, better do that then first. So, yeah, now I forgot the name. Partition iterator. So copy to, let's begin with the header file from partitions.cxx. in line or not in line? It's mostly assert. No, there's a sort in it. Let's just not inline it. I don't know. I'm gonna inline. Well, what the heck? Let's inline everything, really? Nah. Must be something I don't inline. No. Okay, I'm not inlining anything. I mean the other way around. I am inlining everything. So we just keep everything here. It's the whole thing, but we need obviously include for the unique pointer. That's memory, I think. Partition iterator base. What else do we have? Assert, as usual. Well, you never know if that is needed. Elsewhere already included or not, no. And then group, of course. Well, partition iterator base includes everything. So kind of done. And we use guards. Partition iterator base was not declared. Right, so we include partition iterator base and then it is not declared. Probably because partition is including stuffs, because before we do the partition iterator base. Not really. So just including group and element. If that's not possible, then partition iterator.h is included from here. from here, I think. Let's start at this end. We are trying to compile partition iterator base.cxx. That includes partition iterator base.h. You cannot blame it. It's going to define that. And then that file that we just included, completely rightfully, includes partition.h. And I would say that is also required because partition is here a member. Cannot define this thing without allowing our original partition to be instantiated here. So that also looks completely correct. Then partition.h is trying to include partition iterator.h after defining itself. I don't know, it doesn't seem necessary to include partition iterator base. Let's just not do that then. Just for declare the thing, it should work. And then we have an invalid use of incomplete class partition iterator base right there. So it was being used. Well, let's say I insist on onlining this. What I can do is just say, it must be aligned. But then move it down. Sorry, base, right? These could be moved to their own header. Doesn't really matter where I end this thing because we don't do any includes. Let's for now put it at the end. Let's say still invalid. Holy moly, really. Oh, there. Right, yeah, this one's using it as well, of course. And that one and everything. So you have to make them all in line then. Don't you regret that I decided to keep them all in line? I make a mess of it. Friend. I can make a friend and then can I already put in line here? I hope so. Of course I can put it in line here. Now we delete all of this. Move that down here. Invalid use. Seriously? Okay, so the .cxx includes its own header, which is allowed, which needs partition, which is okay, which includes at some point partition iterator, because it needs it here. And then partition iterator fails to define partition iterator base. And the reason for that is that we are already busy including partition iterator base. So including it again doesn't do anything. Oh man, that is mind-boggling. Yeah, I think the trick is you have to absolutely separate everything in declarations and definitions. But that's not possible here. Just cannot move this down. Oof, spare high. I think to make a long story short, I don't want to put too much time into this. It's a difficult sub problem, and at some point you just have to stop caring and just make it work. I think I'm going to start with, of course I forgot completely where I was working with. Let's make none of these inline. Just screw it. Seriously? Still? Okay, so who cares? Or, I mean, I care, but then you really don't have time for this problem. What did I do? I did edit it, but not copy it yet. Okay. No, it's a good thing I didn't copy it. Oh shit, it's a template. Can't do that. Oh no, why? It's forcing me to solve this or what? Nah, that's nonsense. By the time partition iterator is defined, you also have memory, right? Yep. Some clause is in having a standard unique pointer to an incomplete class as a member. And I forgot which one. That one. The compiler is generating the destructor, and then it needs it needs a destructor of this thing, so that doesn't work. I have to make the destructor also external. In order to delay the generation of that member, the destructor of that member. Except of course when it still doesn't work. No, dude. Huh? Invalid use of incomplete class partition iterator brute force. Apparently I'm not actually using score index as function. Let's delete it. Poo-poo. Right, that took a long time just to split up this bloody file. And in the meantime I forgot why I was doing it or what I was about to do. I think I'm going to commit what I did. Let's start with utils. just a few new files. Do I want to keep this or not? So just for, it was generating some, yeah, I think it still has value. Might as well commit it. Jesus. Right, so this still compiles, right? Yes, it still compiles. Okay, but does it still run? That is the question. Also still runs. We can finally go back to something useful, but it's dinner time, so maybe now I should I think I should stop and cook, otherwise the food in my fridge is overdated. You keep counting, Shotgun. I know you. Maybe they keep recommending it because you keep joining. But unfortunately for you, if you just joined now, I'm going to eat because of my health, as it were. I literally bought food and it's still in my fridge and it's getting overdated because I just don't. Well, I eat bread then, instead of dinner. Stupid me.